All right, so now we're going to look at a two-sided test. It says, according to the Centers for Disease Control and Prevention, the CDC website, 50% of high school students have never smoked a cigarette. Taeyeon wonders whether this national result holds true in his large urban high school. For his AP Statistics class project, Taeyeon surveys a simple random sample of 150 students from his high school. He gets responses from all 150 students. 90 say they have never smoked a cigarette. What should Taeyeon conclude? Give appropriate evidence to support your answer. So as soon as I read this, I'm going to write a couple of things down, that P is equal to 0.5, right, because that's what they say that it is, the null. My P hat from his sample is really 90 out of 150, okay, and my N is 150, because I'm going to need those values, and I write them down so that I keep them distinctly different, and I don't interchange them or put things in the wrong place. So he does state he wants to perform the test at a 0.05 significance level. They didn't tell us in the problem. Remember, if they don't tell me, I always assume that it's going to be a 0.05 significance level if they have not specifically stated otherwise in the problem. The null and the alternative is that the proportion is equal to 50, and then he just wants to know if it's the same. So he says that the alternative is not equal to. It doesn't matter if it's higher or lower to him. He just wants to know if it's not the same as the national. And then they tell what the proportion is, and that it's the actual proportion of students in Taeyeon school who would say they have never smoked cigarettes. Again, we're going to tell them we're going to do a one-sample Z-test for the population proportion. We're going to check our conditions. He did a simple random sample, all right? So he checks N times P and N times Q. You get 75 and 75, so they're good. They're normal conditions met. And then independent, multiply 1,500 students. At a large high school, we know that there's 1,800 or 1,900 students here at Franklin High, so a large school should have more than 1,500 high school students in it, so independence would be met. So here we go. We have to do the work. So P hat is 0.6. They get that from the 90 over 150 minus the P naught, which is 0.5, and then they put 0.5 in here, and they get our test statistic to be 2.45. Now, because this is two-sided, look what happens. The p-values, to compute p-value, we find the area in one tail and double it, because we could have, it's either correction, so we have what's the probability of getting this 2.45 or greater, and we get that p-value in the right tail, which is this 0.0071. Again, you can do that using the normal CDF. But because it's a two-tailed test, you have to double to get the p-value. So the true p-value, or the actual p-value here, is 0.0142, which is still going to be less than my alpha. My alpha is at 0.05. So since our p-value is 0.0142, is less than the chosen significance level of 0.05, we have sufficient evidence to reject the null and conclude that the proportion of students at Taeyeon School who say they have never smoked differs from the national result of 50%. Okay, we just have to tell that it differs, and we have evidence to prove that it is different. All right, so the big thing with the two-sided test is that when you get this p-value, you have to double it. The result of a significance test is basically a decision to reject or fail to reject H naught. We reject H naught. When we reject H naught, we're left wondering what the actual proportion of P might be. A confidence interval might shed some light on this issue. So Taeyeon found 90 out of 150 students said that they had never smoked a cigarette before. Before we construct a confidence interval for the population proportion, we should ask both the number of successes and failures are at least 10. Okay, so they're looking at the normal. The number of successes and the number of failures are 90 and 60 respectively, so we can proceed to calculations. So they run a 95% confidence interval, because a 95% confidence interval goes with a two-tailed test with an alpha of 0.05. And they find that for his high school, the actual proportion of students that smoke is between 0.522 or 52.2% and 67.8%, or that had never smoked a cigarette. So we actually know where it should fall. And here we talk about there's a link between, like I just said, confidence intervals and two-sided tests. 95% confidence intervals gives an approximate range for P naught. that would be rejected by a two-sided test with alpha equal to 0.05. The link isn't perfect because standard error used for the confidence interval is based on the sample proportion, while the denominator of the test statistic is based on p-naught for the null hypothesis. All right, so they're showing you this. A two-sided test is significant level and 1 minus alpha confidence level. Okay, give us similar information about the framework. They're showing you where it comes from. If the sample proportion falls in the fail to reject region, like the green value in the figure, the resulting 95% confidence interval would include the p-naught. Okay, in that case, both the significance test and the confidence interval would be unable to rule out p-naught as a plausible parameter. All right, and that's all there is in 9.2.